You might have noticed previously in life that when you ever rub a balloon with your hair, then the immediate effect is that some of your hair will start to freeze, like freeze, right? It's called a triboelectric effect. And you might have noticed that this has to deal with something that we call the charge. You might have the experience if you rub some plastic with fur and the plastic will start to charge, and plastic will have a negative charge, and this is convention, while glass will start to have a positive charge. And then you put these together and they will tend to attract. For instance, if you put another plastic, this will tend to repel. So this gives you a sense of what is charge. Charge, for instance, is a fundamental quantity and is measured in coulombs, a C for coulomb. So what is happening when you rub the balloon starts to charge negatively. And this will induce positive charges in your hair, positive charges, which will start to repel each other. That's the reason why frizz is generated in your hair, because your hair is repelling because of the positive charges. So positive charges and negative charges, they will attract each other, but positive will repel with positive, while negative will repel with negative. And this is mere convention. This is positive, negative. We can actually call whatever, right? This is mere convention, and the convention states this is positive and negative charges. And we have certain particles, for instance, the proton, which we usually state is positive, and the electron, which we say is negative. And both of them carry an elementary charge. And the elementary charge, for instance, stated with E or minus E, the elementary charge is 1.602 times 10 to the minus 19 coulombs, or for the electron minus 1.602 times 10 to the 19 coulombs. While we have another particle, which for instance the neutron, and the neutron has no charge. It's also very important to understand that the mass, for instance, the mass of an electron is 1.109 times 10 to the minus 31 kilograms, while the proton, the proton is a little bit heavier, 1.67 times 10 to the minus 27 kilograms, and the neutron, the neutron is more or less the same as a proton, 1.67 times 10 to the minus 27 kilograms. Very small masses, but they are important. While the charge is another characteristic, right? There is another very important situation with charge. Charge as matter is not created nor destroyed, it is conserved. So, it means that in any closed system, if I have a closed system, I will count the same amount of charges that are in the system. For instance, if I input any interaction with another system, this might move, right? These charges might move, but they will remain conserved in the system. So the principle of conservation of charge states, although these charges can move, they will remain constant. So in this tutorial we explain triboelectric effect, charge as a fundamental quantity, the interactions of attraction and repulsion of charges, that is an elementary charge, the mass of the particles, and the conservation of charge.